Hi there, Rachel Chase here, and in this video we will look at counting principles, which are used in probability techniques because they help us to identify the frequency that something might occur. The first of our four counting techniques is called the fundamental counting principle. The fundamental counting principle says that if you have multiple items and you want to know the number of ways to put them together, all you have to do is multiply. So for example, if you have, let's say, 4 t-shirts, and 3 pairs of pants, assuming that they all match, how many different combinations could you make of these two things? 4 times 3 gives us 12, so that means you have 12 different outfits that you could put together. So if, let's say, you added in, we also have 2 pairs of shoes, then all you would do is then multiply 4 times 3 times 2, which now gives us 24 different outfits that we could have. Factorials are very similar to permutations, which we'll talk about in a few minutes, however a little bit different. A factorial takes some number of items, let's call them n, and says starting with that number you're going to multiply. So we're going to multiply by the number before and keep descending. So it's n minus 1. We have n minus 2, n minus 3, so on and so forth. We get to 2 and 1. Which might be a little confusing, so instead let's look at that as a value. So let's say we have 4 factorial, that would be 4 times 3 times 2 times 1. So starting with that integer, multiplying down until you get to 1. Factorials are used in essentially without replacement situations. So if you're trying to, distribute pens to students, and you need to make sure that each person gets only one pen, once you give that pen to a student, you cannot give that student another pen. So that's the idea. Factorials are often used in race situations, and for that reason, if someone comes in first place, they can't come in second place or third place, etc. Once they place first, that's it. That's all they have. Combinations and permutations go hand in hand. Both are counting techniques where you have n number in your sample space, so that's your size, and you're giving out R number of objects. So again, that's for each of these. Now, we would use a combination versus permutation depending on when order is significant. If the order that you give items out does not matter, then you can say the combination of n with R is equal to n factorial divided by n minus R factorial times R factorial. So there's an extra R factorial in the denominator because you're dividing out the repetition that we have. So what would a combination be used for? Many different cases, one of which could be if you have, let's say, 1,000 songs on your computer and you want to put them into, a playlist of 50 songs and you're hitting shuffle. So it doesn't matter the order in which you arrange the songs because they'll all randomly occur anyway. On the other hand, let's say you did care about the order of the songs. So the order you placed them on your playlist was the order that they maintained. For something like this, you would use a permutation. And that's equal to n factorial divided by just n minus r factorial. So unlike the one above, just n minus r factorial. So keeping in theme of that example, let's go back. Let's make it a little smaller because calculator will overflow for something like this. So let's say you have n equals 50 songs and you want to select 10 songs for your list. If the order matters that you're putting them in, we're going to use a permutation. So if you have to play them in that order, so you would say that would be 50 permute 10 ways. If you want to use the calculator for this, you can. Start by typing in your 50. Then under the Math Probability menu, you're going to select the second option here. You'll notice below that there is a combination, and below that is our factorial key. So what we're going to do here to finish simplifying that is see how it's e here? That means times 10 to the 16th power. So the shortcut to that would be move your decimal 16 places to the right. So that's 9, and then add in extra spaces for zeros. So that seems like a pretty massive number, but you have to keep in mind when the order matters, that's what makes it such a large value. So it'd be 3727, 604, 302, 000, 000, 0. So just add some commas in there to make it easier to read. So obviously a very, very large number. If instead we looked at this as a combination, so what if we hit shuffle? So we don't care the order of the songs playing. That would be 50C 10. You can go back to our calculator like before, put your 50 in, then under your math menu, then put 10. So as you can see here, also a pretty big number, but only times 10 to the 10th power. So that means when we move our decimal place, we're only moving the decimal place 10 times here. Which is still a pretty big amount, but not as bad as the other. And so we're just going to the end of this. So in terms of how would you calculate these things by hand, honestly, you don't have to calculate these things by hand, but you have that option if you choose to, or if your calculator does not permit you to use these functions in it. Most calculators that are scientific or greater will have these capabilities in them. All of these counting techniques can be used in conjunction with probability. So again, keeping in mind, let's say you're curious about the number of, I don't know, royal flushes in a poker hand. Well, there can only ever be, if you're not familiar with poker, that's okay. But in a 5-card poker hand, there's only 4 ways to get a royal flush. Out of how many different ways can you pick 5 cards? Well, once they're in your hand, it doesn't matter the order. So there are 52 cards, and we only need to choose 5 of them. So what's the probability of a royal flush? 4 out of this combination right here. So again, this is the probability of a royal flush. So it's kind of cool to see how these things tie in with the basics of probability. And of course, if you're curious about this, you'd want to turn that into a decimal and probably look at it. But anyway, here are just a couple of applications of counting. Thanks for watching.